So we've come to the point in the lesson where we need a little bit of explanation on how to get the difference between the arrival times of the P wave and the S wave. So when we look at this example, a seismic station records a P wave arrival time of 6 a.m., 28 minutes, and 17 seconds. So this is an important part that we want to kind of keep in mind right here. It then records an S wave arrival time of 6 a.m., 34 minutes, and 3 seconds. So these are the times that we really want to pay attention to. And our goal is to find the difference in the arrival times between the P wave and the S wave. So when we go down here, I'm going to show you how we're going to set this up. 6 a.m., 28 minutes, 17 seconds, 6 a.m., 34 minutes, and 3 seconds. We want to set this up in a way that is going to convey the time. Now, this is a standard way to convey military time, as they call it. 0600 28 17 is 6 a.m., 28 minutes, 17 seconds. S wave arrival here is 6 a.m., 34 minutes, 3 seconds. So again, our goal is to find the difference between these two, and we're going to do that by subtracting the P wave from the S wave. And the reason why we want to subtract the P wave from the S wave is that the S wave has a greater time, and it's always going to have a greater time because it arrives after the P wave does. So we're going to set up the equation like this. We had the S wave time right here, 063403 for our S wave, minus the P wave, which is 062817. Well, we want to go from seconds to minutes to hours and subtract them. But we come into a problem right away because we see here that when you try to subtract 17 seconds from 3 seconds, you can't. So what you're going to need to do is borrow some time from this minutes column. And the way you're going to do that is you're going to actually take a minute away from here. So that was 34 minutes. Now it's going to become 33 minutes. And you're going to add that minute into our seconds column. I'm going to reduce the thickness of this a little bit. We're going to add the minute into the seconds column, but we need to convert it from the minute to the seconds. So if we add 60 seconds, which is in a minute, to this, it then becomes 63 seconds. So now we can go ahead and perform our calculations. I'm going to get a text box going right here. And we can see here that if we go from 63 minus 17 is 46. So we're going to kind of tab over here and say that is 46. And then we're going to go to our minutes column, and 33 minus 28 is 5 minutes. So we can say that is 5 minutes. Not sure why that font is so different. And then that's actually going to be 0.5 minutes. And then 6 minus 6 is obviously 0. So we get a total time difference of 5 minutes, 46 seconds. So we're going to use this difference in arrival time between the P wave and the S wave in order to calculate the distance to the epicenter. So down here, I have some practice problems for you here as far as subtracting P wave arrival times from S wave arrival times, getting those differences. You're not always going to have to borrow time. If your seconds on top are larger than your seconds on the bottom, you can go ahead and subtract those. But you might just want to pause the video here, take a minute, and do those practice problems. Okay, so then when we come down here to actually finding the distance to the epicenter using the difference in arrival time. So here is the diagram from page 11 of our Earth Science reference table. And we're going to take a look at that difference that we just got of 5 minutes, 46 seconds. So this chart here on your reference table has two axes. The y-axis is your travel time, and your x-axis is your distance to the epicenter in thousands of kilometers. So this multiplied by 10 to the 3 km is basically saying that each one of these represents 1,000 kilometers. So let's just take a second here and look at those labels and see if we can come to some conclusions. You have 0 here, you have 1,000 here. So these are each increments of 200 kilometers going up. So these are all 200 kilometers. The travel time in minutes as you're going up, it goes from 0 to 1 to 2, but then you have these tick marks in the middle. And if you count them up, you can see that they're going up by 20 seconds. 1 minute, 120, 140, 2 minutes. So that's going to help us out when we try to work this through. So we have our difference in arrival time of the P wave and the S wave, and we're going to use that to get the distance to the epicenter. So what I'm going to do here, if you are using a reference table at home, you can use a piece of paper to line this up. If you're doing a digital copy on Cami or something like that, you can use a line. So I'm going to go here to my shapes. I'm going to select the line, and I want a relatively thin line because I want it to be as accurate as possible. If you get a thick line, it's going to be kind of hard to read. So I'm going to do a thinner line, do a red color here, and I'm going to kind of zoom in a little bit. So my difference again in arrival time is 5 minutes, 46 seconds. Well, if we look at the increments as these go up, we don't have a 46-second mark, so we're going to round that. We're going to actually round that down to 5 minutes, 40 seconds. So I'm going to start right here. I'm going to put my crosshairs right here. If you're using a piece of paper, you're going to line up your piece of paper flush with this y-axis and make a tick mark right here at 0. And I'm going to take that and I'm going to drag that all the way up to 5 minutes, 40 seconds. And if you're using Cami, it's helpful to hit the shift button at this point so that it makes a nice straight line. And I'm just going to simply click off of that. So if you're using your paper, you're going to pick it up. For us using Cami, we're going to select the arrow here. And what I'm going to do is I'm going to take this line and I'm going to put it right up here. Now the goal here is I'm going to move this line until the top of this line touches the S wave line and the bottom of the line touches the P wave line, and then we're going to be able to use that to determine a distance to the epicenter. So I'm going to go ahead and slide this down, and looks like it fits right about there. Maybe a little bit. There we go. That's perfect. So you can see that the top of this red line is touching the S wave line. The bottom is touching the P wave line. And now I'm going to use this to determine the distance to the epicenter. So all I do is I follow this line down. And if you want to, I think you can even take this and expand it down and see that it hits, again, if we hit the shift button, it'll keep it straight. It hits the x-axis right here at 4,200 kilometers away. So we know that if this seismic station, if we were getting these readings at our seismic station, we would know that the distance to the epicenter of this earthquake was 4,200 kilometers away. So that's just one part of what we're going to be doing to find the epicenter of the earthquake. But this is a really crucial part. So we're going to be going through a few different exercises to practice our skills with this.